Hello, welcome back to another panel. You don't get the illustrious Peter, you get me this time, which is totally fine, I hope. Welcome back, but you do get a fantastic panel. So we're just gonna sit down and get going on the future of open computing, and specifically does numerical computing have an open future, given the diverse array of projects that are emerging and the intense interest from very large organizations on numerical computing. This thing we've been doing, many of us have been doing for many decades, has suddenly caught the eye of a lot of money and a lot of interested parties. And so what will that lead to? And will that enable us to continue with an open future in numerical computing? That's a fascinating discussion. Hopefully it just opens the door. But I want to introduce our panelists here. We have Sebastian, Raschka, I hope I say it right. So many people I get to see their names, and I don't often say their names. Please correct me if I get it wrong.
You got it perfectly right.
Excellent, Sebastian. Sebastian is a professor at Wisconsin, assistant professor at Wisconsin University, correct? And also a collaborator at Learning AI, an educator, a practitioner, wrote a wonderful book on Python and machine learning, and particularly with scikit-learn and PyTorch, I believe. Well-known figure in, if you're trying to learn AI and learn how to do this, you know his name likely. Watch his videos. Paige Bailey, I've been known for a while. She's undergraduate and early career in geosciences, actually. Worked for a lot of oil and gas companies, I believe. And then past decade, maybe at least a decade, I think, you've been doing developer advocacy and really helping people use code better and being a real champion for open source in the industry. And whatever you want to say when I first come to you and you want to introduce yourself further, please feel free to. And then Ryan Abernathey, a well-known open source participant in the Pangeo project, I think Xray, is a professor at Columbia University, and currently exploring kind of how to improve large-scale data analyst, data management. So excited to see all of you here and to kind of discuss this interesting topic. So I think we'll just get started diving in, and maybe just kind of the first question is, give us some, what libraries are you familiar with, just that are not from the sort of NumPy, SciPy, scikit-learn? We have that base of libraries that are open source. What other projects are you aware of that have kind of emerged around that space, and kind of who's sponsoring them? And then what do you, what excites you about that? Let's just start there.
All right, so maybe let me get started. So personally, I have been using open source libraries maybe for 10 years now, and the way I got into this was kind of like through like the community, but then also there was this one little library, let's call that Vector Lab, which it wasn't super fun to use. It was very hard to install, so there was like this Octave workaround. I had to do that in grad school to submit my homeworks in pattern recognition and stuff. And then I got really into Python and NumPy, and the question was more about other libraries that I use. I must say these are still my go-to, maybe because I'm like old school, but I would say they're just simple to use. I'm familiar with them. But then on top of that, you have a lot of new libraries, let's say, focused on particularly deep learning. Maybe if you are familiar with those, they kind of they look under the hood a little bit similar to NumPy, where you have an array structure, let's say PyTorch, JAX, and so forth, or even QPy, which is kind of like NumPy on the GPU. And these are, I think, like I wouldn't call it the next generation of libraries, but these are kind of like, I would say, extend certain use cases to make that more useful for deep learning. So I think a lot of focus is currently on these libraries, which are developed by big companies. So there's a lot of company backing behind these libraries. So, but before, let's say, I go further into detail, I mean, there are also then on top of that, even other libraries, for example, PyTorch Lightning on top of PyTorch, and then Haiku on top of JAX, and so forth. But maybe, Paige can tell us more about that.
Excellent. I love that so many of us got started with open source software when we were in school. Like as Travis mentioned, I was a geoscientist, geophysicist by background. And I also did some research in the planetary sciences. And instead of using this very painful software package called IDL, I began to investigate alternatives like AstroPy and some of the other Python numeric tooling that gave a much friendlier experience. And when TensorFlow was first open sourced in 2015, that also gave an alternative to doing like this very meticulous sort of bespoke hand-by-eye classification of earth sciences features. You could instead use computer vision techniques to do the classification automatically. So many libraries kind of developed around TensorFlow. You're probably familiar with things like Keras as a high-level API, and then also some of the other more domain-specific libraries, and then many around PyTorch as well, and again around JAX. So we have Haiku as kind of a higher-level library, as well as Flax, Chex, Pax, Optax, Equinox, lots of things following this like OX or AX naming convention scheme. And they're really all built around this kind of long tail of use cases, because so many people are investigating how data can be meaningful within their specific domain. And they're all experts, but sort of maintaining these biosciences or geosciences libraries over time is an immense challenge, and not really one that we have a great answer of how the community can kind of rally around and support those maintainers.
Okay, yeah, this is an easy one for me to answer. I want to use this opportunity to really just plug Xray. You know, I don't know if it's up. I don't think it fits into that category of you know, it doesn't have the popularity of pandas, but for us, it occupies a very similar space in that it sits on top of NumPy, or in fact, any NumPy compliant array API, and offers that pandas level of you know, cognitive load lifting, labels, indexes, queries, and it just happens to map pretty directly to the dominant sort of file formats and data models that are used in a lot of scientific domains, particularly geosciences where we use say NetCDF or HDF files, and so I think it's tremendously underappreciated actually in the ecosystem. It can offer multi-dimensional array analysis, that sort of pandas level convenience. And so if that's an easy one for me to answer, and everyone should go out there and star Xray on GitHub.
Perfect. That was exactly what I was hoping you would talk about, Ryan. So excellent. So this question is, does it have an open future? Open is a pretty generic statement, and there's a lot of kinds of open. So I want you to, the next question is sort of, what do you think the open future should look like? What does openness mean in this context? I've been writing about community-driven versus company-backed open source, for example. That's one dimension you could discuss. But just anything you think about, what does it mean to be open?
Yeah. Oh, no, I was just going to say thank you so much for clarifying that open can mean many things, right? It can mean open frameworks, open libraries, but also one of the things that we've been thinking about very seriously is open data. Are the models open, or are the source code for the models open, or are the sort of the weights being added, or is it kind of all of the infrastructure required in order to re-implement the model? Does that exist externally? Not every company has compute and storage access to be able to re-implement something like DALL-E or one of these other large language models. So in terms of openness in those contexts, I really, really hope that that's something that we move closer towards as a community. But there are a lot of significant hurdles between now and that bright future that I don't think that we've been planning for.
Yeah, so also, getting to the point, like, what does open mean? So first, like, the big question is, does it have an open future? I mean, it's an open-ended question, right? But yeah, I think, what we've seen in recent years is, like, when I started, it was usually like, you put something on GitHub and then it was open source. But I think we are just about getting started with that. I mean, just in the previous panel, we discussed different strategies around organizing and monetizing open source, or let's say supporting open source. And I think we are just getting started in terms of thinking about how to really make this, let's say, maintainable, feasible, and how to kind of structure the community around an open source project compared to, let's say, how we did that before, just putting something on GitHub and hoping other people will help contribute. So I think, yeah, we have an open future where we also just getting these things figured out, how to organize these things. On top of that, just the point you mentioned with this open data aspect, one thing I kind of like worry a little bit about is we still make these tools that are super, let's say, accessible from a user perspective, but looking at the recent, let's say, cutting edge libraries, let's say PyTorch and JAX, for example, I feel like as someone, I'm very comfortable using them, but contributing, becomes harder and harder. I think maybe because these libraries become more and more specialized, but you have to have way more knowledge now about, like, let's say, even CUDA programming. And CUDA programming is something, let's say, I'm in statistics, I'm not really familiar with that part. I'm focusing more on, let's say, the analysis and computations rather than the engineering. And I feel like, we are kind of making these tools maybe so specialized and complex that, yes, they are still open source, but can we really still contribute to them easily? So, that is, I think, something I think about, and there's no right solution. If you want to make these tools efficient, you have to put like a lot of sophistication into it, but yeah, something to think about how we deal with these situations in the future, I think.
Yeah, I'll follow up on both of those and try and share the perspective of like the sort of academic research world and what open means now. I'm not sure how much people realize just how much the winds have shifted in federally sponsored research towards what we call open science, right? NASA is leading the charge. Every NASA-funded proposal now must have an open source plan. Like, they have to release their code open source. The data has to be open. It's fantastic, and they're putting their money where their mouth is. So my good friend and colleague, Shel Genteman, is now leading this initiative called Transform to Open Science, run by NASA HQ. Their budget is $10 million a year to advance open science. So the flip side of this is, so this is all great, but now there are all of these scientists, and not just PhD students, but mid-career scientists who are being told, you must now be open. You have to open source your code, and they don't know how to do that. And so I think this community can really help science by showing what it means to be a really effective participant in the open source ecosystem. Because, like, as you mentioned, like, well, anyone can just say, okay, here's like the scripts I use for my paper, throw them up on GitHub. Like, that's kind of step one in an open source journey. Something that's much harder is to think, where can we actually contribute upstream to advance our needs and like the community's needs in one go? And I feel like that's where our Pangeo project has been pretty successful, thanks largely to a partnership with Anaconda that we started at the beginning, where we just, rather than trying to hire like another postdoc, we're like, let's just give like money to Anaconda to like consult on this project and help us figure out how to be more effective open source contributors and teach us how to like implement CI on all our like projects. And it was very effective. So I think we could be doing that sort of activity on like a 10x scale or 100x, and the science community would actually eat it up. There's a very open future in science, but someone needs to sort of lead the way.
That's fantastic. Sounds like you gave the pitch for OpenTeams, actually. So come talk to me later. We'll explain. But it sounds to me like you're all saying yes. I mean, I think the question, does numerical computing have an open future, really depends on the funding, depends on where the motivation and where the money is coming from. Sounds like with the federal government pushing openness, with many companies recognizing that at least the foundations of what they build has to be open in order to get buy-in if they want mind share. What are the other factors that are driving an open future? What motivations drive an open future?
I mean, also,
Quick it doesn't have to be a long talk.
I mean, nowadays, it's like a little tangent, but I always tell my students, it's like, if you want to, let's say, contribute, or not contribute, but you're looking for a job at some point, and let's say a GitHub profile is one of the big things on your resume. That's like, let's say, a very, I would say, not selfish motivation, but there is, it benefits the community, you benefit yourself. I think there's a drive towards this, and I can't, for example, imagine going back to the days where I had to, let's say, install and get a license for MATLAB and things like that. So I can't see really why we would go back to the days where everything is closed. I mean, the world, I mean, at least when it comes to scientific computing, runs on Linux after all. So I don't see any change why that would be. And even if you think about administration hurdles in, let's say, academia and bureaucracy, I do think that open source is the only way really we keep things feasible for people, because otherwise it becomes a nightmare, like as a lab managing software. When I had my lab, I was using also computational biology software, which was licensed, and it was like a pain to just get this and download this every year, renew the license, and so forth. So people really, I mean, the open source is really helping a lot of people, making life easier. And the contributions, I think, I mean, they come from both sectors now. It used to be, I think, more academic. Now we have also a lot of big companies, industry contributing, which is, I think, I mean, I would say it's overall still a good thing, so something to think about. But yeah, I do think everything is pretty healthy right now. We are still figuring things out, how to build the communities more efficiently and inclusive, being more inclusive. But I think we are on the right path here, and I think there is an open future.
And to Sebastian's point, I think it's also, for research, the only way that you can really have effective collaborations across different organizations. So Google, DeepMind, they collaborate with many universities around the world. You can't really expect students to be able to purchase software licenses or to be able to kind of spin up infrastructure that isn't reproducible in a way that open source supports and then other frameworks potentially don't. And it's also been like really a blessing to help with recruiting, honestly. Like if you're able to observe a person's work, see that they've built a library on top of your framework, and then they've also submitted a few pull requests or even just filed issues or built tutorials, you understand a little bit about how they work, right? And they've gotten a taste of what it feels like to work as part of your team. So we've hired very successfully across all of Alphabet many of the people that have contributed to Jack's higher level libraries or to other places around our numerical computing frameworks. So it's been great also from a perspective as well. I'm not sure if folks are familiar with the Outreachy scholarships or Outreachy internship program, but they're paid internships for people from underrepresented groups in tech. And they are paid for about 3 months out of the year to work on open source software projects under the guidance of a mentor. And through that, you can, again, kind of understand how they work. But for, you know, a woman who is perhaps entering back into the workforce after having a baby, or, you know, a college student or somebody who's attempting to create a career change, it helps them get involved with OSS in a even if they might not be able to make it through like a traditional interview process in the first place. So that's like fingers crossed, again, like great things that are made possible by open source that wouldn't be possible otherwise.
For Outreachy, it's an amazing program. Let me inject some controversy, because this is all very much peace and love stuff right now. But let's, you know, what are the threats to the open future, right? Let's connect with the previous panel. SaaS, right? I work with, you know, large data sets in the cloud, so I love SaaS, right? Like it really, like, and it's now possible to string together a complete data science workflow just through SaaS. You know, you have your SaaS ETL, and you have your data warehouse, and you got your, you know, dashboards, and that's very powerful, and a lot of companies, you know, work that way today. I'm thinking, you know, the modern data stack and all of that infrastructure. There's some open source in there. But is that open? Do we consider that open when those are sort of single installation, you know, proprietary closed platforms for running that SaaS? How does the growth of the SaaS ecosystem, which is I think a necessity to deal with the challenges of contemporary data and computing, how does that interact with open source? And so this connects to what the previous panel was talking about quite a bit, and this is something I think about all the time.
That's perfect. So that was actually the next question: is what are the threats to openness? So you've segued that precisely. Do you have, Ryan? Do you have anything to say on that front, and in terms of other than what you just described?
Well, we've gotten to the point within science right now, like academic research, and I won't speak for industry or any of that, where we're like pretty comfortable paying for the cloud. Like we'll pay AWS, but like we can't. It's complicated for us to like say pay for coiled. Like that's a much Like it took my university 4 years to negotiate the contract with Google Cloud, right? Like that's the sales cycle for academia. So like using a lot of like fast-moving SaaS is not really an option for us. And so we're kind of required to, in a way, use open source infrastructure more. And so there's a lot of interesting companies, not even companies, but projects in this space, like Binder. This is SaaS, but it's not venture-backed, corporate-controlled SaaS. It's a community-driven SaaS. There's 2I2C, the International Interactive Computing Collaboration run by Chris Holdgraf and the Jupyter folks. They're providing SaaS, but they're doing it in an open way. So I would like to see more stuff like that emerging, but it's very challenging.
Yeah, the funding models are definitely something that has to be explored there because it's a donation-based versus company business-driven. Anyway, Paige, what do you think of the threats?
So to piggyback off that a little bit and to also call out one of Sebastian's earlier points around, just open sourcing something doesn't mean helping maintain it or helping people use it or sort of doing the very, very hard work of community building. And one of the things that scares me a little bit, at least in the deep learning space, is that we really have a zoo of tools. We have so many things popping up, being popular for a year or two, and then winding down either because they don't have community support or they have lost, the backing of whatever corporation was initially sponsoring it. Or, it's just very, very hard to bring life into these projects long term. And I think that we're doing a little bit of a better job of nurturing the software engineering components. So things like doing CI/CD, like making sure that the software is actually maintainable and that it might be performant over time. But we aren't doing a great job of building tutorials, educational content, helping people understand how they might go about filing issues, and really helping with those aspects of growth. I thought Quantsite is doing a great job of encouraging those sort of behaviors within open source projects.
And one point also to piggyback onto your answer is comes back also to the question, how do we define open? Because we have a lot of big companies now, let's say, contributing to open source, having these very popular libraries out there. They are open source. If you look at the code, you can download it. But it's depending on the project. Let's say they don't accept community pull requests. It's only internally in the company, pull requests are submitted, and it's all transparent. But is this open source? I mean, the code is open source, but it's the definition of it. It's still, in a way, a company project that is not really, let's say, developed by the community. It can be downloaded by the community. So in that case, it is kind of I would say, almost I don't know, software 2.0 in the terms of being totally binary code versus now open source code, but it is still, I think this is maybe a hurdle there where we, still the company's agenda, and it's not really the community. The question though is, does every project have to be maintained by the community? Because it's also a burden, right? So it's sometimes maybe a blessing when someone takes charge of it, you are just using it, you don't have to worry about it. So in that sense. The other thing, how to see or how to look at SaaS, so SaaS, basically, so coming from academia, it's very hard to, let's say, justify paying for something because academia wants you to pay for people, not for things like hardware or software even. And so what is the model here? How can we, companies also, they need to support, let's say, open source development, but also infrastructure is not free. So how do you, let's say, make this really easy? And I think, at Lightning, for example, we have an option where you can run things locally. If you don't have infrastructure, you can use the cloud, but of course the cloud is not free, let's say AWS or something, but there's also an option to bring your own cluster. And I think this might be a solution where I feel like this is a fair thing where you may have infrastructure at the university and the open source software, the SaaS, sits on your cluster rather than, let's say, a cloud provider as an additional option. I think that might be...
Great job. Yeah, excellent. We're about out of time. I want people to spend 10 seconds just describing what the most critical things to stay open are. Just summarize your position, say what are the critical things that you think need to stay open. You got really 10 seconds, so summarize quickly. I'll let you think. Ryan.
Formats and protocols for data exchange.
Awesome. Reward the people in your company who are doing open source work and make sure that it is looked at just as favorably in their performance reviews and through promotions and those sorts of things. The community building and glue work is real work.
Yeah, also the community for sure, like making sure people are welcome to contribute, and also listening to the community in terms of we are building this for the community, so also including the community feedback, I think is very important.
Excellent. Great job. Thank you, everybody.